All right, so I got to go shooting today. I needed to check 0 before I go hunting in a couple weeks and got some interesting stuff to talk about, I think. So the real point of this video is some target software that I've made. So I wouldn't really call the software an alpha, far from a beta. I'd say it's probably more bugs than code currently. It's a lot of chat GPT and I'm not a programmer, but it is kind of functional. So I've got two versions of this program. One is automatic and the other is a more traditional manual program. And I really based the manual program off of something that you can get as an app on your phone called Range Buddy, and I use it a lot, but I really couldn't find a good analog for this on a desktop computer, and so I kind of made my own. And that led me to make this target, which the automatic version of the program is calibrated to. And this thing is kind of interesting. So I've got all these target points. This target is designed for a very accurate rifle. Today I was shooting a rifle with a hunting scope and it wasn't zeroed for this ammo because I didn't want to waste my hunting ammo on this thing. But this is a full box of the Hornady Match 7 PRC 180 and I'll show you how it works. So let's go over the computer and show you some target programs. All right, so let me show you what I got. Now, I'll start off showing you the automatic version, and it's the one that is probably less useful because it's so specific to the target that I created, but it's a Python script, so you'll need a fairly recent version of Python to run this. If we open this thing, I'm using idle as my development environment, and so up at the top, I have, made sure that you understand you do need Python. You need some other Python add-ins. Now with that, I'm just going to go up to run and run this module. So you can adjust your display. And so this is going to set the screen size. So I'm on a big monitor, so I'm going to make that thing pretty big. On my laptop, I can adjust it to be smaller, and that was helpful. For the holes, I shot a 7mm, so that's 284. The rest of this stuff I added in just for like debugging purposes. I wouldn't really mess with it unless you really need to for whatever image you're working on. There's also a little toggle that I can show you all of the steps that it takes to do this. So let me go ahead and turn that on. And so you'll see a bunch of intermediate images where it does all the corrections and stuff. So there's the update. And so it says, all right, let's select the base image. So this is the base image file. And so that thing is called GT4. And then I'm going to select the image that has been shot. And so that's the shot target here. And would you like to perform a manual alignment? So I'm not going to do that. I am just going to let it run. So hit no. And basically that manual alignment, if you see there's all these fiducials on here, and if you want to do manual alignment, you go through and you click all these in order from left to right, top to bottom, and then it will do some morphological correction in case you have like a bunch of distortion in your image. I mentioned that it's going to show you all the intermediate images. So here is the base target image. Hit the space bar and it's just going to flip through. There's nothing to do. I'm just showing you the images. This is the refined image after it's done some image correction to make it kind of square and flat. So then it goes through and it thresholds basically to eliminate everything, to make everything black and white. So this is the target, the base image. Here is the target that I shot. And you can see that's what the thresholding does. It turns it all black and white. And you can see that now the holes show up really, really nice. So this is the base image. Basically, I then close all the tiny holes. And this eliminates all the little dots so that the program doesn't get confused. It only leaves, so on the base image, you don't see anything because it closed all those holes. Here is the refined image that I shot. And you can see after this step, it only leaves these big holes. So that makes them very easy to identify. Then it blurs. So again, the base image is blank. Here's the refined image. So this kind of softens and makes the edges a little smoother. And then we do a difference. And so we're finding what are the differences between these two images. And so again, now we have identified the holes. This cleans them up a little bit, and then everything gets mapped and located. So the final step, because it's basically done, is I recognize that it's not perfect. So there's a remapping that you can do. So if I move this out of the way, I can say, all right, well, look, this hole actually needed to go to that target point. It knows where all these target points are. So I don't have to be super precise. Let's see, this one should go up there. This one should go right there. This hole goes right there. This one goes right there. Okay, so everything is now mapped. It says hit the escape key on the image when you're done. If you click on something that's not a hole and not a target point, it won't do anything. You can see there's nothing found at that position, so hit escape. It's done, so now it's going to output the image that has been mapped in, and then I can output all the data into a CSV. So that's it. And here's what shows up. So you've got, this is the raw target with the data plotted on it. It's showing you, hey, here's where I found all these holes. Here's all the target points that they're mapped to. And then there's an associated hole mapping CSV. So let's open that up. And here's the data. So let me format this really quick. All right, so what does it give you? Well, it gives you the X and Y coordinates in inches of all the holes and all the target spots. And it gives me the delta in the XY dimension. All of this is in inches. And then it gives you the radial distance. This is basically how far away from the target point were you. And the nice thing about this and the way I built this target is I'm not shooting groups. Each shot is relative to a very specific point. And that means these deltas I can then aggregate to find any statistic that I want, be it like circular error probable or DRMS or anything like that that you want to do, more advanced statistics, which are more appropriate for really identifying accuracy. Well, there you go. And this target can have up to 30 shots on it. And so if you've got a really accurate rifle, this would be great to capture a 30 observation sample size, which is what I intend to do with it going forward. All right, so that was the automated target analysis program. So let's close out of that one. All right, so let's run the manual. All right, so the UI, I apologize, it is very small. I'm, again, just aiming for functionality here. I am not an expert on building UIs, so I'm sure this can be changed, but for now, I'm just trying to make this thing work. So in the upper left, I'm going to load an image. This does not have to be anything special, any target, because all this is going to be manual. So I'm going to load in my zero check. And you do have some ability to pan and zoom with a mouse wheel. So I'm going to get this thing kind of blown up where I can just focus on what I care about. Then you can also rotate this stuff if you want. I wouldn't worry too much. You just want to make sure it gets oriented correctly. And then you're going to do perspective correction. This is going to flatten and square the image up for you. So you do clockwise, left, right, bottom left. So I'm going to go right here, then right here, then right here, and then right here. And it's going to crop and square everything up. Now, you do have to be pretty careful. Again, this is not a robust program. There's a lot of ways to break it right now. So I'm being careful to do everything in order, but you can see it did a fairly good job squaring this image up. Next, we need to calibrate the image. So it says click 2 points and then tell us how far there is between them. So I'm going to click right there and say that's 4 inches. Okay, so tells you, okay, well, there's your pixel per unit. This is unit agnostic. You could have done this in millimeters, whatever you want. It doesn't matter. So bullet diameter is 0.284. Okay, and now I select my target points. You can do multiple target points wherever you wanted to aim at. And so this is on release. So whenever I get to the center of my target, I then release. There's a marked point. Then I can click select holes. Same thing. Click and then position your hole where you want it. Then release. I understand you probably are going to have problems seeing these little rings on my screen. I can. I probably need to make those thicker. It is what it is for right now. So I've got my holes marked. Then I'm going to assign the holes to the target. So there's the hole, there's the target, and you can see it does give you a little bit of indicators. You do have to be kind of precise here. because it will try to identify holes that are overlapping each other. And so you do have to click kind of the center of the hole, or else it won't find what hole you're looking for. Okay, so now I'm going to group these. You don't have to group them, but if you want to know a group, right now all it would give me is just the deviations away from center if I finished, which may be enough if that's all you care about. But if you also want to know stuff about groups, I can assign holes to groups, and you click and you can see you do have to be kind of precise on the center. So I've got all these holes. It says, look, this is a 1.72 inch group. By the way, yes, this wasn't the most accurate. This first top shot, that was the cold bore shot, and I'm shooting with a suppressor, so I think it took a couple shots before the thing settled in. I can now select Finish Group, and if you wanted to do multiple groups, you can do that. I've only got one, so now I'm going to click Calculate the Deltas. So there you go. It's got everything mapped out. Now I can just export this thing as an CSV. So let's do a test 2 and hit save. And there you go. Now my data is out here in test 2. And there you go. There's our data, right? And so again, you've got the target center, the X and Y for the shots, and then you've got the deviation, so how far away you were, radial distance, you've got bullet diameter, you've also got, if you need it, the pixels per inch, and the group size with which group that was for. And so all this gets put out into Excel or a CSV. That way you can do any sort of data analytics that you want. Now, both of these programs are written in Python, and so I'm going to post this code. So you can feel free to, port this thing to whatever you want. You can, take this and modify it to your content. I will probably do a little bit of development, but not much, because it basically does what I want right now. It's not very robust. Again, I wouldn't even call this alpha software. It's just more of just me messing around. So yeah, I'm sure there's a lot of other features that people might want, but I don't really need more features. So I would say, if you want more features, fork it, put it in a chat GPT, and, let it add features if you want them. But that said, it's working for me. So that's it. They are pretty simple to use, although, again, I expect anybody that tries these things, you are going to find a lot of edge cases where I have not through how things can break. Again, I expect plenty of bugs. I can't guarantee that it works on anything, except I have tested it on Windows 11 and I have tested it on Fedora. So, there it is. So as far as accuracy with this thing, on the automatic program, I made up a test target. I marked all these holes with an all with a little bitty tiny hole, and then expanded it so that I would know exactly the center points of all these holes, just to see how well it does. And the average positional error on all these holes was something like 0.016 inches. So less than 2/100ths of an inch average positional error. And that to me is extremely good. It's probably better than I could actually measure these by hand, because whenever you have a hole, it's really hard to know whether you're in the exact center. So the reason I knew where the holes were is because, well, I put them there, and so I knew exactly where I'd located every single hole. So it is a very accurate method, with the caveat that sometimes it can blow up with the calibration and the image correction, stuff like that. But when it works really, really well. So that's going to wrap up this video. So again, these are like demo versions of software. I'm going to put them out there. If anybody wants to play with them, feel free to fork these things, add to them, whatever you want to do. They're not products. I'm not looking to make money on this. I'm not looking to make programs. I just wanted to do this for myself to see what was possible. But as long as you want to use them, feel free. If it's not for commercial purposes, if you're not going to repackage this, put it in a product, then I have no problem with that. And if I see some cool stuff, I may reincorporate it back into the original version. We'll see. I may try to refine them for my own use. And if I do, I will post the updates out there. Anyway, if you got any comments or feedback, as always, feel free to leave them down below. Thanks.